Hey everyone, welcome. I am absolutely thrilled to have you all here as you step into your new roles. Welcome to this explainer, which we've designed specifically as your foundational training material. Our main goal today is to give you a really rock-solid understanding of the flow meter technologies you're going to be working with, recommending, and troubleshooting literally every single day in this industry. So whether you're coming to us with a deep technical engineering background, or maybe you're totally brand new to industrial instrumentation, don't worry. This session is built to give you the confidence you need to get out there and succeed. Let's dive in. All right, here's a quick look at the roadmap for our explainer today. We've got 1. Introduction to flow meters. 2. Mass versus volumetric flow. 3. Exploring the main technologies. 4. Selection and sizing criteria. And finally, 5. Installation and field realities.
Okay, Part 1, Introduction to Flow Meters.
So what are we actually dealing with here? At its core, a flow meter's purpose is simply to measure the flow of a fluid, whether that's a gas or a liquid, between 2 points in a process. Now, you might be wondering, why does that even matter? Why is there an entire massive global industry dedicated just to this? Well, the data from these instruments is exactly what helps our customers make sense of their incredibly complex processes. It lets them control their product quality, dictate manufacturing speeds, and honestly, most importantly, lower their operating costs. Without this crucial measurement, they're essentially flying blind. And when you actually see these things out in the wild, plumbed straight into a process pipeline, you realize they act as the central nervous system for the whole plant. They're gathering all that critical data. Sometimes they're just passively measuring the flow, but other times they're hooked up with a valve to create a flow controller, which actively regulates the fluid rate in real time. This is the actual hardware you'll be sizing up and recommending to solve real-world engineering problems. Moving right along to Part 2, Mass vs. Volumetric Flow.
Okay, this is a massive distinction you absolutely have to nail. When you're talking to a customer, you need to know right away, do they want to measure volume or mass? See, it's absolutely crucial to grasp that volumetric flow is entirely dependent on temperature and pressure. It's usually measured in units like milliliters per minute or cubic meters per hour. But here's the catch. If the temperature or pressure changes, the physical volume of a gas expands or shrinks, right? And that totally throws off your reading. Mass flow, on the other hand, measures the true physical mass, using units like kilograms per hour. Mass doesn't care if pressure or temperature fluctuates. It stays exactly the same, making it incredibly stable for really critical applications. Figuring out which one your customer needs? That's step number 1.
All right, Section 3, Exploring the Main Technologies. You are definitely going to want to memorize this cheat sheet. It's going to be your absolute best friend when you're comparing options. Let's run through the heavy hitters. First up, electromagnetic, or mag meters. They use magnetic induction. The huge win here, no moving parts and crazy high accuracy. The bummer is they only work on conductive fluids, like water or wastewater. Try it on hydrocarbons and you'll get nothing. Next, electronic meters. These literally use sound waves. They're amazing because they're totally non-invasive and perfect for clean liquids. But if there are air bubbles or suspended solids in the mix, they start losing accuracy fast. Then we've got Coriolis meters. These are the gold standard for directly measuring mass flow. They offer unparalleled accuracy, but yeah, they are definitely on the expensive side and can be super sensitive to bad installations and vibration. Finally, vortex meters. They measure the frequency of vortices created by a little obstruction inside the pipe. They are incredibly tough, handle high pressures beautifully, and again, no moving parts. But they really struggle with accuracy if the flow rate drops too low. Now, taking a look at how these diverse instruments are packed into physical processing skids, it's a real eye-opener, isn't it? Look at how tight these installations get. This is a great reminder that we can't just flip through a catalog, pick a meter based on a single spec, and call it a day. We have to match the technology to the process reality. A big, bulky meter simply isn't going to fit in a cramped enclosure. And a meter that's sensitive to vibration, well, if you install it right next to a massive, shaking industrial pump, it's going to fail. Simple as that. Which brings us nicely to Part 4, Selection and Sizing Criteria. When you're looking at a client's system, you've got a very strict 5-step checklist here to make sure you specify the exact right instrument. Step 1, what's the fluid phase? Gas, liquid, vapor? Some meters eliminate themselves right out of the gate here. Like we said, a mag meter can't measure gas. Step 2, what is the flow rate range? You need the minimum and maximum to make sure the meter stays accurate across their whole process. Step 3, check those pressures. You have to know the inlet and outlet pressure to figure out the pressure drop and to ensure the device won't literally blow out under maximum pressure. Step 4, temperatures, both the fluid and the ambient air. Extreme heat or freezing cold can completely fry the meter's electronics. Step 5. Where is this thing actually going? Is it in a nice, climate-controlled lab, or is it sitting outside in a freezing, hazardous oil field? You've got to verify those IP ratings and special explosion-proof certificates.
Now, as you guide your customer through those 5 steps, you're inevitably going to hit the budget conversation. It happens every time. Your job here is to help them balance performance versus price. Customers always want the cheapest option, right? But as this quote nails perfectly, prioritizing price usually means you're getting a basic instrument with less than average performance. It's on you as the expert to help them see the bigger picture. Investing in the right technology up front, even if it stings a little at first, is going to save them massive headaches, huge maintenance bills, and disastrous process errors later on.
And finally, Part 5, Installation and Field Realities. Okay, this is a stat that blows a lot of newcomers' minds. When a client builds out a new measurement system, the physical flow meter hardware itself usually only makes up about 35% of the total cost. That is a huge blind spot for folks entering the industry who think the shiny hardware is the whole investment. Yeah, in reality, the remaining 60 to 70% of their budget is completely eaten up by the engineering, the custom piping, the complex wiring, and getting the whole system commissioned. So what does that mean for you? It means your advice on how they route their pipes, where they place the meter, and how they wire it is honestly just as valuable as the meter you sell them. You could sell them a perfectly calibrated top-of-the-line Coriolis meter, and it will give them absolute garbage data if they install it right after a crazy turbulent pipe elbow, or if they don't shield the wiring properly. Your expertise in installation is what guarantees that the massive 60 to 70% they spent on engineering actually pays dividends. Right now, the global flow meter market is absolutely booming. We're talking a $12.14 billion industry today, and it is projected to surge toward almost $19.5 billion by 2034. That means countless industries out there are upgrading, they're expanding, and they are desperately relying on experts like you to guide them. So as you step out onto the floor armed with all this new knowledge about mass, volume, sizing, and the harsh realities of field installation, I want to leave you with this exciting challenge. When a client brings you a near impossible process and a tight budget, which flow meter are you going to recommend next? Welcome to the team, guys. Let's get to work.